Hardy always first. Is
Yes.
Nirma train?
Yeah.
Which subject I taught? Maybe ICA.
EDC, I guess.
Okay. कहाँ है क्लासमेट आपके सब अभी जॉब कर रहे हैं एमएस? Shall we start?
Yes, sir.
Okay. So we started with that previous session designing of NOT gate, which is very fundamental gate in the digital design with some resistive load RD. Designing it means always you have to find out aspect ratio of the transistor as well as passive elements. So we come to the conclusion that RD into W by L, that number is 22.22K. That relation is available. So we take multiple value of W by L and we'll see what is the effect on RD as well as average power. So average power value I will give you that it is nothing but VDD into ID. ID we know that it is VDD minus 0.2 divided by RD. And if I am assuming that Vin is low during 50% of operation time and VDD and input is high during 50% of operation time. So it means my VDD is VDD by 2. For 50% of time my input is low during the operation and remaining 50% of time my input is high. So my VDD is VDD by 2. That means that is the average power dissipation formula. Now your task is to give me the value of different RD and different power. This number for W by L 1, 2, 3, 4, 5. 5 answer you have to give. So start with W by L 1. What is RD and what is power? Use your calci, pen and paper. So you are getting what you have to do. Yes, can anyone reply?
Can you repeat it once?
Yes, sir.
Yeah. Hello,
हाँ एक
Yukesh.
बार रिपीट कर दीजिए ना सर.
So yeah, RD into W by L we've calculated 22.22K. Now I have to take different value of W by L 1, 2, 3, 4, 5. Corresponding what is the value of RD from this formula, and average power also you have to calculate by this relation. So multiple RD, multiple power, multiple W by L. So start with first W by L is 1. So RD is 22.22K. What is power? Average power VDD by 2, VDD minus 0.2 by RD. %50 time I assume VDD input is VDD and 50% time it is 0. So this VDD by 2 into VDD minus. Okay, someone written in the chat box. Let me check the chat box. 64 microwatt. I hope remaining answer. Let me check other answer someone get other than this number. If it is the same one, then I write here. So Subham is replied 64 microwatt. Yes, Pujan is also saying same. So I write 64. So write down for remaining 2, 3, 4 and 5. Pujan, very quick, 129 for next. But what is RD? Also, same time, give me the RD. RD is half. So what is power for this 2? W by L equal to 2. This stuff you check, it is correct. 194 microwatt or 129. You can unmute and also you can also speak. No problem.
129.
129. Okay, thank you. 129 microwatt. Now 3, 4, and 5. Remaining 3 answer.
Sir, 194 microwatt.
194.
94 microwatt.
What is RD?
Uh,
7.4.
7.4.
Okay,
answer.
correct. Now 4 and 5. W by L.
4 RD is 5.55.
Okay. Power
259.
259. Okay.
Fifth
Last
4.44.
last one.
Yes.
4.44.
44.
And power
Power. Just wait.
324.
324.
Okay. So what are the observations from this number? This is one column W by L, second column RD, third column power. Yes, Ayush, you are not audible. If you want to say, still you are not
As
audible, Ayush.
as aspect ratio increases, RD is decreases and power is increases.
So which number you select?
The first one.
But RD requirement is large,
Sir,
20.
lower RD because at after all, when increasing the number of stages, it was bad for input resistance high.
Pujan, can you repeat one more time?
So lower RD because after increasing of stage of number of gate, the input resistance was high is very bad impact of next stage as I
Yeah,
thought.
yeah. Actually, depends on our requirements, applications. If we are, it's not like that every digital circuits, in every digital circuit, we have to achieve everything. So if you have an entire system on chip, SoC, some part gives good performance, let's say in terms of area, some part give good performance in terms of speed, and some part of your SoC give good performance in terms of other performance parameter, let's say power. So in entire SoC, different areas are there where you have to optimize the result. It's not everything you achieve from SoC or an entire system. So let's say I'm having this number, first one, where my W by L is this one I pick up. RD is 22 kilo ohms while my power is 64 microwatt. For example, if I want to use this inverter, you know cochlear implant something.
Yes, sir.
Yes, sir.
Yes, good. So it's a one kind of hearing aid which is by surgery it is mounted inside the ear. So for that also circuit is available and we have to supply the power. This is just I am giving the example. So this is extremely low power circuit is required. It's not like that after 10 days, 20 days, again you have to do the resurgery and change the battery. 30 years, 60 years, maybe that battery should be working without any charging. So in that case, low power application, digital hearing aids, also hearing aids are mounted outside the ear and frequently 15 hours, 20 hours that battery should be work. So for that extremely low power applications, nowadays trend is ultra low power. You can use ultra low power is in not microwatt, power is in nanowatt. So for that kind of applications, you can definitely go for first one. Now we'll see the very important relation. As you said me that ID in the linear region, mu and ux W by L VDS VGS minus VTH minus VDS square by 2, and graph is like this: VDS versus ID. So if your VDS is 0, what is ID? Yes, please. If VDS is 0, what is ID?
0.
Oh,
0. Now suppose my VDS is 0.1. What is ID? Just give me the formula. Which term is present in the bracket? First term or second term?
First term, sir.
Why first term? Answer is correct.
So the
Because
second term is
Sir,
the
because of
square is going to be approximately 0.
yeah, is square and by 2 and
Second term is
definitely
very small.
small as compared to 1. So in that case, my change in VDS, okay, I can write mu and Cx WL is VDS approximately VDS VGS minus VTH. So I can say that my change in VDS, if everything is constant, VGS, VTH, WL, means my change in ID is proportional to the VDS like this. Whatever I change VDS, same amount my ID is changed. You agree with this sentence?
yes, sir.
But it is provided small value of VDS.
Yes, sir.
Let's say I take 0.2, 0.5, something like this. But if I'm taking this little bit higher value, okay, let's say I'm taking 1 volt, 2 volt like that. So in that case, what will happen? You cannot neglect this second term if your VDS is larger. So in that case, if it is not large, you cannot neglect. It means with same amount, your ID is not changed if there is a change in the VDS. Your ID change is different and your VDS change is different. Again, if you take some different value of VDS, which is larger than 1 volt, 2 volt like that, you cannot neglect this term. You have to consider this term 4 square by 2, let's say 16 by 2, 8. You cannot neglect as compared to first term. So non-linearity is started. Graph is look like non-linear. Once you take higher and higher value of VDS, non-linearity is introduced. Graph becomes non-linear. So if you tell me if I want to use this device fully on, it behaves as a small resistor. Which value of VDS I have to take? Very large or very small?
Small, sir. So
Yes,
small.
small, because if you see if you plot the VI characteristics of resistor, it is straightforward. Okay, linearly proportional to the voltage and current, Ohm's law. So only in this region, probably second also if my VDS is small. Only in that region I can use my device and it behaves as a resistor. So if I am writing the ID in linear region for register, it is look like this: mu n cox W by L only VDS into bracket VGS minus VTH. I am not worried about the nonlinear term because my input is small. Okay. So now can I find what is change in ID by change in VDS? That is my RDS. I can say it is 1 upon change in ID by change in VDS. Can anyone find what is this number? It is
Sir, 1 upon mu and C of
right.
W by L,
Correct. VGS minus
VGS minus VTH.
okay. So this is my RDS or RD on. Very important formula. If you want to design any any MOS, sorry, any register value by using MOS, you can use this formula. So if I want to design for 22.2.2K, what is the value of L? Very large or very small as compared to 4.4K? L.
Sir, large.
Of course, it is large for 22K as compared to 4.4K. So L large, it means I have to work in 1 micron technology. I have to maybe work in 1 micrometer technology, which are source and drain distance is very large. So I cannot design my hearing aid if I want to implant inside my ear, or if I am not using any small or low, ultra low power design where size is a constraint. Okay. So of course 64 microwatt we get the advantages, but size is a problem. Area is a problem here. While here area requirement is small, but you have to compromise for the power. Power budget is higher. So it's not a straightforward. You can say that this you can use this one like that. It's all depends where actually your target applications, where actually you are going to use this mechanism. You are going to use this design. So area register value is larger. Of course, power is small, but area requirement is large. That is a problem in this design. Is it okay?
Yes, sir.
Yes, sir.
So let us move for the next performance parameter with this application, not gate. Same circuit. ये dotted line में क्या है? इसको क्या बोलते हैं? What is the name?
Capacitor.
Bypass. Which
It's a
capacitor?
bypass capacitor.
No, bypass capacitor.
Coupling capacitor.
No, it's not coupling.
Junction capacitance.
Capacitor.
Junction, stray or parasitic capacitance,
Yes.
which is always there. Okay. Junction cap, or if it's not like that, in the entire system or in the entire SOC, I have only one gate. So many gates are connected like this, maybe other gate also. So the input capacitance of the next stage, because input side also here we have a MOS, and MOS is a very good example where your gate is isolated. Gate is isolated with substrate by SiO2. So is a one kind of capacitor, positive plate as well as negative plate. So capacitance always there, maybe next stage input capacitor or parasitic capacitance of this device. So if you have a MOS like this, many main junctions are there. This is my substrate, drain, gate, source. So all the way, these are all the capacitance. Tray capacitance, CGS, CGD, CBD, like that. So this is parasitic capacitance is involved. And we have seen in the yesterday lecture, if capacitor is there, it takes some time for charging and discharging. So whenever I am applying some input 0 to 1, okay, if my input is 0, it means this MOS is off because it is enhancement type MOSFET. It requires VGS up to VTH to become as on. And then if this MOS is off, my entire current is flow via this path. It means capacitor starts to charge. If capacitor starts to charge, definitely it takes some finite amount of time to reach to the maximum value VDD from 0. So what RD you require? Very large or very small if you want to charge the capacitor in less time?
Full.
RD is
Small. Small.
someone sitting in train maybe. RD requirement is low. Then and then I can say my capacitor charging less time. Reverse is also true. Once my input is logic 1, enhancement type MOSFET, it is in on state. So this capacitor get only path for discharging via MOS device. So in that case, you have to ensure that there should be no any current is flow via RD. Okay. So your RD value should be what? Very large or very small?
Large.
Very.
Large.
You have to make sure that current is passed only via MOS. Current is not passed via RD. So in that case, my RD should be higher. Then and then your capacitor discharge via this MOS quickly. And output is fall from logic 1 to logic 0. So there are two conflict requirement if you see. How you can desolder the register, manually connect high value, low value. How it is possible? No way it is not possible. There are two conflict requirement to get the high speed. In one case, your R is slow. In second case, your R is high. How you will do in IC integrated circuit? How you open the package and you can see the result change in the R. Is it possible manually? Please speak.
No, sir.
Can you repeat the question?
My question is that if you want to charge and discharge this capacitor very fast it means let's say input is logic 0, MOS is off, entire current is flow via this path, capacitor is charged. If you want to charge the capacitor very fast, okay, this is well known formula. Current should be larger, time should be smaller. So current larger, it means R value is low. And in second case, when I apply the logic 1, MOS is on, your capacitor is fully discharged via this path. It should be current should not be passed via resistor RD. So in that case, your R value should be higher. So two conflict requirements.
Sir, can we put a register in emitter side? Sorry, the source side, low register.
And from where you will take the output?
At between drain and RD.
मतलब यहाँ पे.
We can put a small register there.
And if you take output from here, it is
No, sir. No, sir. Output between drain and RD.
So still your capacitor is discharged via this. It should not be passed, current should not be passed via this RD. So RD again high you require.
Can use active load.
Which load? Active load?
In CMOS we use PMOS for pull up. So it
Here.
will be off while discharging.
So any device, electronics device, active device, if it is in on state, it gives smaller resistor. If any active device is in off state, it gives the larger resistor. So we use PMOS as a load, NMOS as a driver as it is, and no change in NMOS, same NMOS. And we apply common input to both. So if you apply logic 0, this is on, this is off, the entire current is flow via this capacitor, but at the same time it is on, it provides R low. So my this condition is satisfied. If your input is logic 1, this is on, this is off. So if it is off, it provides larger resistance. Entire current is flow via this path. So second condition is also satisfied. So this name is a CMOS complementary metal oxide semiconductor that gives the high speed. This CMOS gives very high speed. That's why your and all ICs, the trend to use the complementary CMOS metal oxide semiconductor logic. Hello, are you able to hear me?
Yes, sir.
Yes, sir.
Yes, sir.
So
Yes, sir.
this is the first advantages. Can anyone tell me both switch, in which situation both switch are on? Both NMOS and PMOS.
Transition region from 1 to 0, 0 to 1.
Like this or like this. Both are transition regions. Which you see?
Sir, in second one, because when it gives up
Second
to
one,
50%.
yeah. If your
Second one,
input
sir.
is, yes, correct. If your input is slowly change, if your input is slowly change, it is possible that both NMOS and PMOS are on. If this is the situation, the current is flow from VDD to ground, and there is a power dissipation. Otherwise, only one switch is on, either upper one or either lower one. There is no complete path from VDD to ground. But if your input is slowly changed, whose rise time is very large, okay, in that case, you can say that there is a short circuit power dissipation. Otherwise, any one switch is on, so power dissipation almost negligible, almost zero, less power dissipation. There is no any requirement of 22 kilo ohms resistor, something like that. No area, big area is required for this physical resistor. You only everything you have to implement with W by L. So area requirement is also small. So these are the good part of the MOS design. Whenever you open any textbook in any course of VLSI design, next 2 semesters, you find this logic. Upper side is our pull-up network, always PMOS. Lower side is our pull-down network, always NMOS. If you interchange the place of NMOS and PMOS, which function it is?
The buffer.
Yes, it is called buffer, which is
Buffer.
which is very commonly used in the interconnection. Whenever large interconnection is there, whose critical delay is very large, so you have to break that wire into small pieces, and you have to use buffer in between. that match the impedance of two lines and your propagation delay is reduced. So interconnection, definitely we have a use of buffers. Okay. Have you received any mail from my side? Because I find some issue
No, sir.
because your email ID is outside the Nirma Uni ID. I cannot send the exe file to you for any kind of software. And also your recently received maybe mail from university, your email IDs are available. Is it true? You got
No, sir.
No,
some
sir.
temporary. Okay, okay. But we got some message. So you have some temporary roll number. We'll see definitely. So what I was planned that I am going to demonstrate this spice coding for our require MOS. Anyone know this about something about this spice code?
No, sir.
Okay. So spice coding we are going to I'm going to demonstrate you, and later on if your email ID is available, definitely I will share all files with you. But before that spice coding, let me tell you what are the tools available in our lab that you can access very easily with some open source also. So I'm going to list down the tools available with us. EDA tool, electronics design automation tools. At each abstraction levels, if you start with the specifications, okay, you have to go for the logic design, logic verification. First stage, logic design, logic verification, whether your circuits will work or not, that you have to functionally verify. Okay, so for that given specification or given design, you have to write down VHDL, Verilog code, nowadays system Verilog. Okay, everything will come in this next 2 semesters. So VHDL Verilog code you have to write down for given design, maybe half header, full header, ALU, like that, and then you can generate the simulation for that. So Xilinx ISC is available with us. Xilinx ISC with model sim full package. You can use this for your VHDL Verilog simulations. Even that, whenever we go for the next stage, once you generate your netlist of your logic designs, you have to enter into the physical design. Okay, so this is one tool, Xilinx ISC full package with us. Once you are writing or generating the netlist, you have to go into the physical design flow, where from circuit netlist you have to generate the layout. That steps or process is called physical design. That is our course title. So we have a full tool available from Cadence up to 45 nanometer technology. Three technologies provided: 90 nm, 180 nm, and 45. Full tool is there, Cadence for circuit simulator as well as for the layout. So in the Cadence, we have one more part for physical design, which is called Cadence Encounter. So where in this Cadence Encounter, our all the experiments are based on this Cadence Encounter, except first few experiments where we have to pass our design from each and every steps, step 1, step 2, step 3, step 4, like that, and then finally we get some layout. So all the majority 80% experiments are based on this Cadence Encounter. But because of this situation, COVID-19, you are not able to access this cadence encounter. So open source are also there, similar to this encounter. So first is Magic for physical design, and second is Proton. I hope you note down this because this is also the question by the interviewer, that which tools you know at which levels, or which are the open source available. Hello, anyone writing this?
Yes,
Yes,
sir.
sir.
Yes, sir.
Good, good.
Yes.
So Magic and Proton is a open source. So I plan already all 18 to 19 experiments, 8 to 9 experiments that is on the Proton. Is very well used in the e-info chip. Maybe you know the company name. Open source is available. Once you are here, then we'll start with Cadence Encounter also. Okay. So entire physical design is possible with these all tools, with the available with the Cadence. Apart from this Cadence, we have another tool also, which is freely open source available for circuit level simulator, which is called Simica. You can work up to 180 nm technology, no problem, with Simica. Similar kind of GUI available like Cadence. So it is freely available up to 180 nm technology node. Simica EDA. We have total 10 license of this Cadence. Apart from this Simica EDA for circuit simulator as well as for layout generations, we have another tool which is called Tanner EDA. Now initially it was Mentor Graphics, the company. Now it is merged with Tanner EDA. So we have total 25 license for this Mentor Graphics or Tanner EDA. You can do circuit simulations, you can generate the layout of small circuit like that. Apart from this layout, we have another tool also of more than 20 license. It's a Microvin. Probably you know in your BTech. Microvin for layout. So that tool is also there. If you want to work at the device level, also we have a tool available. It's called Visual Ticket. That is at device level. So in one of the course SDPM, you are going to learn this software in the lab, device simulator, Visual Ticket. So we have total 10 license of this Visual Ticket, where you can generate your own device. If you want to generate 0.2 diode, possible. Any multi-gate devices you can fabricate, you can design in this software, and you can simulate also. Visual Ticket. This Microvin you are going to learn in the lab. The name is the digital VLSI design. In this lab, you are going to learn this Microvin. Visual Ticket in your SDPM. SDPM is your course name, Semiconductor Device Physics Modeling. Tanner EDA or Mentor Graphics, Analog and Mixed Signal Design. Simica EDA is also for that, Analog and Mixed Signal Design. Maybe you know the subject name. Yes or no? First
Yes,
semester.
sir.
Yes, sir.
Good, good. This cadence encounter total flow in this VLSI physical design course. VSDL Verilog also you are going to learn. Maybe by Salim MM started that. So in the cadence encounter, this part is also we are going to cover. We are not going to pick up any direct netlist. We are going to do first logic simulations of logic design, and then we use as a use for the physical design. So Xilinx Viado is fully available with verification and everything. So this is the tools with us almost for all the level of abstractions. What we don't have any tools for packaging because it is after the fabrication. So we don't have any tool. We have all to up to the GDS2 graphic design system 2 you can create it. Graphics design subsystem you can create GDS2 file. You know that in Foundry always we have to give this GDS2 file. Okay, from that they are fabricating the device. So any doubt in this tools?
No, sir.
No, sir.
Okay, so now next 1 hour I am going to demonstrate the T-Spice for the MOS device characteristics. So SPICE, anyone know full name of SPICE? Simulation program for integrated circuit emphasis, SPICE, and Tanner company that provide that is the T-Spice. So is it visible this once you click on the .exe this window will appear to you. Is it visible to you?
Yes, sir.
Okay. So we are going to write down the new file and from that I will step by step I will explain how you can see whatever tool I written in the previous slide at backend always this spice code is there. That's why I thought that at least you understand the spice code what going behind this all software. Maybe it is any one, maybe Cadence, maybe Mentor Graphics or anyone. So backend side always this spice is available. If you use multi-sim, we drag and drop the components at backend side. This spice codes are running. So it's a very powerful tool for circuit design. Okay, it's very powerful tool for the circuit design simulation program for integrated circuit and emphasis. Up to 1000, 2000, if number of transistors are there, you can do the simulation, circuit simulation using this spice. Okay, so let's begin. So click on, is it visible this everything?
Yes,
Top
sir.
menu.
Yes, sir. Yes, sir.
So I will start with the first menu file where I have to click this file new. Okay, which you want to write. So definitely always we are going to write some code, spice code. We are not going to use any ready-made model or we are not going to write any C language here. So it is a spice, T spice you have to pick up. So this editor window will appear. Okay, this editor window will appear where you have to write down some code, spice code for the given circuit. So I will start with the MOS characteristics. Then we'll switch to the what circuit we have find out that is the design in the theory class inverter. I'm not going directly the inverter. First line is always comments. So you write some program name, maybe your MOS characteristics of MOS characteristics. Okay, maybe it is NMOS or PMOS. At present we are looking for the M1 NMOS. Now in the spice, one thing you have to remember, everything on the spice is working on numbers. Okay, so suppose if I want to design some circuit or MOS characteristics like this, I have to apply some VDS and I have to apply some VGS, gate to source voltage. Okay, VGS, VDS. So I have to use some number for this. Source and substrate always with 0. We are ground because it is NMOS. This drain I am giving the number as a 2, and this gate I am giving the number as a 1. Okay, so I have to define the MOS with this number. One number is the gate, two number is the drain, source and substrate are the 0 0. Okay, so that numbering is very important. If you do the mistake in number, your circuit is not according to the your require. So remember, D drain at present it is for 2 number, gate is for 1, source and substrate are the 0 0. So I have to use this coding once I want to define in my code. So next line after the comments line, you have to define the MOS, let's say M1. Now 2 1 0 0. This is the pattern. Can anyone tell me which terminal is first? 2 means
2.
2 number, it means drain.
Hmm.
1 number is gate,
Gate.
source and substrate. So fixed sequence is there. If it is M1 number is there, M1 transistor is whose first number is D, G, S, S, drain, gate, source, substrate. Then I have to give the MOS name. Let's say at present I am using NMOS. Okay, whose W by L I have to define 5 micron, for example, and L I have to define, let's say 1 micron. That depends on your calculations, whatever. So this is first line to define the MOS M1. Okay. Next line, you have to define the supply. My VDS is available between which 2 points? Can anyone tell me? Drain to source voltage.
2 and 0.
2 and 0. Okay. So 2 and 0 I am applying, let's say 1.8. I am working in 180 nm technology. Gate and source is available between which two?
1 and 0.
1 and 0.
1 and
1
0. Yeah.
and 0. Okay. Let's say it is also 1.8. Next line is very important. The name of that line, that is called the model file. How you can define this model file for all the parameters. Let me share that file with you for 180 nm technology. This one. Is it visible on your screen? This is notepad file.
Yes.
This is level 49. Nowadays level is 56 or 55. Okay, level it means start with level 1, level 2, level 3. If it is level 1, it's a very basic model with very less complexity. Just what equation we have seen today morning. ID saturation equation without any body bias, without any channel length modulation, like that. So there is a basic level 1 model. If you add more and more complexity, more and more parameters, model is, number is increase. This is for 180 nm technology. In this model file, we have, this is given by the foundry. Okay. Once they are fabricated the device, they generate this kind of file for the software. So it is NMOS and PMOS, for, it is available for both. Here you can find TOX, which is available in our formula mu and UX. UX is nothing but UX by TOX. So that TOX is 4.1 into 10 is to minus 9. Threshold voltage 0.393. Okay. Mu 0, mu and CX, that I told you 280. And for calculation, you have taken 300. So these all required model parameters are mentioned for NMOS and PMOS in this model file. So whenever we write, or if you use this Cadence or any mentor graphics tool, this model file always you have to add for your simulation. Otherwise, your device is not identified. It is from which technology node. So this is given by the foundry. We are going to add this file in our Spice code. So if you add this file in your Spice code, it means all the VTH, mu and CX it will consider. Okay. So the command is dot include. You have to give the complete path from where in your desktop it is available. Okay. So just I am finding where this 180 nm file is there, and then I give the path of that file. Is a notepad file. So it is available in E drive. This spice MTech 21 batch 180 nm.txt. If something wrong, definitely it gives the error. So I given the path of that model file. It's 3 and 1. So as per our schedule, you have to take the break of 10 minutes. Hello,
Yes, sir.
Yes, sir.
and take water. We'll back at 10 or 3:10. Okay. So once you are back, then we'll start. Shall we start?
Yes, sir.
Yes, sir.
Sir.
Okay, so this we are doing to plot the MOS characteristics. Then I will give one exercise also to you that you have to finish before 4 p.m. today. So first line is comment lines, always title of your code. Second line is always you have to define the MOS, DGSS, define W and L. Third and fourth, there is the supply, VDS, VGS. Now you tell me if you want to plot transfer characteristics of MOS, which voltage you have to vary? If you want to plot transfer characteristics of the MOS, which voltage you have to vary?
Sir, VGS.
Yes, transfer graph is the VGS versus ID. So that value is my DC value. Okay. Always the name of that source is VGS as we define in the fourth line. Yes. And then I have to give some range of this VGS. Okay. Let's say it is start from 0 to 1.8 with 0.01 increment step size. So dot DC is my DC voltage, VGS is the variable name, and then its value is changed from 0 to 1.8 with the interval of 0.0. So first value is 0, second value is 0.01, 0.02 like that up to 1.8. Now next I have to plot the ID. So for that I have to use this print statement. Print is a command that used to plot the any parameters. So DC value I am going to plot, and that is the current for MOS M1. And finally I have to end the code. So print is a command to plot ID of M1 with corresponding VGS from 0 to 1.8 with interval of 0.01 and dot n. Then simply, so do you want to save it? Yes. Select any folder on desktop where you can.
This is case sensitive.
Yeah. This is MOS first experiment, maybe any T spice, whatever name you want to give, and start simulation. So this is VGS versus ID. VGS versus ID. Can anyone tell me from this graph what is a VTH0 from graph?
Nearby 0.5.
Yeah,
0.5.
yeah, exactly here 0.5. Okay. What else we are able to find out from this graph? Let's I put some cursor also, horizontal and vertical cursor. If I take the slope of this graph, what is that? Huh? Yes, someone speaking.
GM, transconductance.
Transconductance if I am take the slope of this graph. Correct. Can anyone tell me what changes I have to do in the code to plot VDS versus ID? What changes I have to do in the code to plot VDS versus ID?
Sir, take a VGS constant
Yes.
and vary VDS.
Okay. So VGS is my 1.8. So that I keep fixed. Only I have to change here. Okay. And again ID, that is VDS versus ID. So let us see.
What is .dc?
.dc is a command that indicates that your VDS is your DC value, 0, 1.8, any value. Is a .dc, DC value. So this is find my VDS versus ID. If you take the slope here, you will get RON, just you discussed in the beginning, RON. If you take slope here, you get some more parameters that is called channel length modulation factor in this region. So now you have to open the Word document or Notepad file, okay, in your system, where you have to write down the code of the circuit that what we discussed in the class, or maybe it's there here. Yes, I'm going to sketch that circuit again one more time. For that you have to write down the code, whatever RD value we have select. Let's say first one 2.22K, and corresponding W by L was also there, 1. So all of you start to write in your notepad and you have to share your screen. Write down the code of this circuit.
Write in notebook.
Notepad, in your system there is a notepad or Word of Microsoft Word. You have to show me that code by sharing your screen.
Sorry, sir. Okay, sir.
Vary VGS 0 to 1.8. All of you getting the task? Mangesh, Himanshu,
Yes, sir.
Gaurav, Nirali. Anyone? I will ask anyone to share their screen. So all of you
And
write.
this is N for NMOS.
Nmos.
So the circuit is not visible.
Yeah. Let's say now it is visible. The circuit what we have seen morning, same circuit, theory class.
Sir, in this, first you have to write number and then you have to write the
Yeah,
value, or first you have to write the value and then you have to write the number. Suppose,
first M1s, then 2100.
sir, that I wrote, but in second line, suppose I have to give the value to VDD. So VDD, then what I
So
have to write?
VDD, let's say it is between here. This is your
Yeah.
VDD. So
Yes.
you have to give number also. Let's say it is 3. So between 3 and 0 you have VDD
Okay.
1.8. If you are ready, you can just give me the call. I might stop my sharing. You have to share your screen. At a time, only one student can share. After you are just joined because you are not present initially.
Sir,
Yes,
the step size has to be same for gate to source voltage 0.01.
yes, you can keep that also. You can keep zero point 0.1 also, no problem. 0
Ah,
0.01, 0.05.
okay, okay, thank you.
Smaller the step size, better will be the graph.
Sir,
Yes,
sir, in the NMOS W and L, we have to mention it.
yes, you have to mention in second line after the comments.
Okay, sir.
Can you show previous code?
You can share your screen, Mangesh.
Sir, I just forgot all things. I remember only 2-3 lines of program
Okay, no
code.
problem. I am sharing that screen also. This one. This is for MOS characteristics. You have to do some modification based on that circuit.
Sir, I have written a code. Can I share my screen?
Yes, let me stop my sharing. Then you can share. Now you can share.
Yes, sir. Just a minute.
Yes, Sivang is first one that going to share his code. Jamin, okay. Jamin is sharing. Okay, let me check. Spice core. First comments we have to put the star 2100. Okay, VDS. VDS is not where is register? Jamin, where is a register? You modify again, but register is not available.
Sir, can I share?
Let me only one student can share at a time.
Okay, sir.
This is Jamin. You can stop.
Sir, my laptop got hanged.
Okay. So if anyone else is ready, they can share.
Sir, can I share?
Yes, Jamin, you stop sharing.
Sir, can I share?
Just a moment, someone stop sharing. Jamin, stop sharing. Then and then you can share. Jamin, please stop sharing.
Share in video call, sir. There is no present.
Just Jamin, you stop sharing so someone else can share. Meanwhile, you correct your code. Hello, Jamin. Jamin कहाँ चला गया?
सर उसका इश्यू लग रहा है, कुछ नहीं सुनाई दे रहा होगा उसको.
उसको मैंने टेक्स्ट मैसेज भी किया. Someone sharing the video. Jamin, stop. Then and then I can see others. Are you did prepare a WhatsApp group for your classmate?
Yes, sir, we texted him that to stop the sharing.
I am also planning probably on this Sunday to interact with your interaction session with your senior, those who are doing the internship.
The Gemini is saying he's not in the meeting.
But he is available on the screen. What to do?
Sir, can you disable the share option from your side? That can be.
Already disabled.
Okay.
Yes, now it is there. Now anyone else can share. Someone else can share. Now Jamin stop. So Dhananjay Nayak is going to share his screen to show the M12100 NMOS. इसके साथ ही लिखना है, एक ही लाइन में लिखना है. M12100 NMOS WNL. Okay. RD. This is wrong. VDD.
Sir, W is equal to 1, na? Because W by L ratio was 1.
Yes, W is 1 micro, L is 2. Okay. RD is 20. Do not switch multiple times. Okay, keep this screen as it is, Dhananjay. So RD is between 2 and 0, 22.20. No, it's not like this. 22,000. Only that way you have to write down. 22, then 30. RD is not written properly. VDD is not between 2 and 0. You have to take one more node. Let's say 3. Between 3 and 0, you have to connect 1.8 VDD. We are not going to change the VTH. You are not going to change the VTH. You are going to change the VGS. वो भी लिखा नहीं है आपने. VGS कहाँ पे है? VGS you have to mention like VDD.
Okay, sir. Yes.
Now you stop sharing.
Yes, sir. Yes, yes.
Yes, Gunjan, are you ready? Can you share your screen? Gunjan Goswami.
Sir, if I can share.
So can I share?
Yeah, one by one you can share. Yukesh, now you share.
Yes, sir.
You are sharing the video.
Yes, sir.
I have to close. Yeah, let me check. NMOS M1 VDS. Okay, VGS RD between 3 and 0. Include dot VGS. Only one mistake. Second line. Find out what is a mistake. You
Okay,
have to
sir.
plot. You have to plot VTC, not characteristics.
Okay, sir.
Okay. Stop sharing.
Sir, can I?
Yes, you
Register
can.
does not have
Yes, you can share the screen.
लेबल सही नहीं है
Register का
लेबल
label. See this screen. M22100 NMOS WL VDD 30. Okay. VGS 10. Fine. RD is not okay. RD is between 2 and 3. Correct. 22. A dot include that file dot VGS 0. Only second print command is not proper. You have to plot VTC. X axis input, Y axis output.
Okay,
So
sir.
everything is correct. Only second line you have to recorrect. Yes, you can stop sharing.
The main share.
Yes, you can share. So click on share. Select your screen to share.
Mm.
Can you share your screen? Gunjan is sharing, but no sharing option. No sharing message.
Sir, may I share?
Yes, you can share, Gunjan.
Sir, Himanshu here.
Oh, Hemansu. Sorry. Gunjan Goswami. Gunjan Goswami is sharing. So M1 NMOS WL okay 2100 VDS 30 okay VGS 10 RD is wrong. RD is between 3 and 2 22,000 dot include dot VGS. Okay, second line is not proper. We are not going to plot VGS ID. for NOT gate. We are going to plot V inverses view. So only small correction, Gunjan. You can stop sharing. So I try. Rest of you can see my screen, what change I am doing, and you follow whether you are changed this same or not. So it is MOS based inverter M12100, no change. VDS, I little bit keep more accurate between 3 and 0. One additional component I have to put as a RD between 3 and 2 whose value is 22K or 22K also you can write, or 22,000 also you can write. VGS as it is, this I have to change. VGS 0 to 1.8, and this I have to plot two value. One is input, that first you have to write down if you want to plot on x-axis, and second that is output after that. See the code. And MOS W1.
Sir, in this, if you have included 3, then we have also have to write in the second line 3, number 3. Otherwise, how it will be
I am
written?
not clear. What you say, Subham?
Sir, in second line, we have not written 3, but in third and fourth line, you are representing the 3. That means,
Oh, terminal number 3, which is VDD for 3.
yes, sir, but you haven't included in the second line, terminal number 3.
This is for MOS only for MOS.
Okay, okay.
Let me try to run. So this is the voltage transfer curve. Is it visible?
No, sir.
No, sir.
No, sir.
Why? Is it there or not? Ayush?
Screen is blank, sir.
Blank.
Blank screen, sir.
Let me share again. Now,
Yes, sir, it's visible.
Yes, sir. Yes, sir.
Yes, sir.
this is the voltage just you have seen morning. It has some negative slope also. It has some positive slope also. And this is our input signal. Change from 0 to 1.8. If you not write V1, only you will see this green line. So this is voltage transfer curve for our circuit. What changes you will do to make this curve as ideal? Can anyone give me the hint? ये जो ट्रांजिशन रीजन है वो पूरा फ्लैट चाहिए, तो आप कैसे करोगे? This is too long. It is not a good inverter.
सर रजिस्टर निकल देंगे.
रजिस्टर तो चाहिए हमें अभी, यही सर इसमें ही कुछ चेंज करना है विदाउट changing the components. This all component as it is. You are getting my question. You need this kind of sharp change.
लार्ज VDS वेरी करेंगे.
VDS is also fixed. 1.8 is maximum. You cannot change more than that.
तो चेंज वो VGS 0.01 के जगह कोई लार्ज वैल्यू चेंज करें तो.
Let me share the screen again. It was stopped for some reason. Now all of you follow this. Let me change the value of RD and see what is the effect. Still as it is or something changed. Are you able to see my screen?
Yes, sir.
Yes, sir.
Is there any change you observe with higher resistor?
Yes, sir.
Now it
Yes, sir.
becomes less
Change in slope.
placing, changing the slope. Let me take few more value. Now see. But what price you have to pay?
More size.
Yes. बहुत बड़ा ट्रांजिस्टर चाहिए इसके लिए आपको. So area is a constraint to get this ideal inverter. So next task, okay, I am going to sketch the circuit of CMOS inverter. For that you have to write down the code. जो आज हमने वो देखा ना starting में same circuit. Now I replace resistor with PMOS because resistor is not a good candidate. Okay, it requires large area for the sharp cutoff. Now use this circuit, give proper number, write down the code for this. This is PMOS source यहाँ पे इसका common input. This is 2 by 1. This is 1 by 1. This is VO. This is VDD. Let us see who will give the first answer. Jamin, are you saying something but not audible? My screen is visible.
Yes, sir.
Okay, so for this circuit, you have to write down the code now. PMOS ऊपर है, नीचे NMOS है. Give proper numbering. Then I will tell you who will share your screen. So Nirali, are you doing some work or you are using cell phone?
Still writing.
Cell phone or laptop?
No, sir,
Desktop.
I said laptop, but I'm
Okay.
still writing.
Okay. UKS is using laptop. Am I correct? UKS? More
I am
mobile.
on a mobile but using laptop.
On mobile using laptop. Okay.
So next time on laptop.
Okay. Purchase नहीं किया अभी ऐसा है.
No, sir, purchase laptop, but I did not install WebEx there.
Oh, okay, okay.
Next time.
So give proper numbering because two transistor, one is NMOS, second is PMOS. Let's say this is M2, upper one, lower one, M1, or you can take anyone. So in any software cadence, every backend side, this is the heart of the any software. That's why I thought to start with this. You can understand circuit. Do not take too much time because we have to simulate also. So 45, 15 minutes we have, no problem. We have enough time. So if you're done, then you can share the screen. Oh, current is very quick. Let us check. M1 is 2100, M2 is 3100, 31 मतलब ऊपर का 3100, 3103 ऊपर का ट्रांजिस्टर है उसको 3 सोर्स एंड तो सोर्स में भी 3 आएगा ना M2 के करंट सोर्स एंड सबस्ट्रेट बोथ आर विथ VDD तो पहला नंबर ट्रेन पे 3 नंबर नहीं आएगा ट्रेन पे 2 नंबर आएगा फर्स्ट M2 के फर्स्ट M2 का फर्स्ट 3 नहीं है वो 2 आएगा यस बोथ आर शॉर्ट सर्किट देन G इज 1 M2 का जो G है गेट वो 1 है एंड सोर्स सबस्ट्रेट जो है वो 3 है वेयर VDS इज अवेलेबल ओके नाउ इज करेक्ट दोनों का WL भी थोड़ा अलग है M2 का 2 1 है और M1 का 1 1 है मैंने जो सर्किट बनाई थी इसमें सो चेंज WL M2 का 2 by 2 सॉरी 2 by 1 M1 का 1 by 1 यस बाकी V1 प्रिंट में 2 बार नहीं एक V1 एक V2 और जो आउटपुट नोड है वो V2 करेक्ट now Karan you stop sharing correct now it is
So should I share?
yes you can share
Sir, can I?
wait at present Ayush is going to share then after Nirali or maybe
Is it visible?
yes it is visible CMOS M1
Yeah.
M2 yeah yes it is visible CMOS M1 M2 3 VGS okay perfect no change absolutely correct stop sharing Nirali you want to share
Yes, sir.
you are in train maybe or in the plane some surrounding sound is going on so you are working from air CMOS 2100 yes 2100 2133 PMOS VDD is 30 perfect VGS 10 include DGS okay correct absolutely correct now you get some hands-on so you can do if you have any complex circuit also you can do now you stop sharing oh yes I know you're at home now not in train okay let me share my screen so M1 2100 W by L okay M2 can anyone help me M2 is what 2100 it's 2 okay 133 PMOS W is 2 new L is 1 new VDD is okay no RD VGS as it is okay VDS okay perfect only small change let me check the VTC now see is it there in your screen my graph
No, sir.
No, sir.
stop sharing and again share now
Yes,
Yes,
sir.
sir.
Now it is visible.
so which one is better this one is better I think without Small without large
Yes,
area.
sir.
Absolutely
Yes,
sharp
sir.
cutoff. Okay, so there is a one big chapter in the digital VLSI design DVD course that you are going to perform in microwin software layout. Directly you are going to sketch the layout. So this is much better as compared to that resistive load. Not kit. Let me give you 10 minutes is left. Let me give you one more task. These are the companies, different companies that give the Tanner give T Spice, Synopsys give H Spice. This is P Spice from the from the National Semiconductor. This is NG Spice, all the Spice version for Spice Core. Okay. Now next task for next 10 minutes, you have to plot the transfer characteristics of PMOS. Let us see what we'll do.
For different spice models, all codes are different or same.
Maybe they are using plot instead of print. That small change is there. Nothing great change. But the general method is like this.
Okay.
So for PMOS, you have to plot the transfer characteristics. Let us quick. We will do. PMOS थोड़ा confusion करता है. NMOS only for learning purpose. PMOS for confusion. इसका substrate ये है, source ये है, gate and drain. I am doing the work in this bulk जो substrate है ना उसमें मैं काम कर रहा हूँ. My research instead of gate.
Sir, done.
Let me stop my sharing. You can share now. Pujan is sharing. Pujan is very quick. From which college, Pujan, you are?
Sir, Dharamshi Desai.
Your code start from where? Yes, MP. Okay. 0122 ऐसे zero कौन सा दिया number? No, source is not zero.
Sir, drain,
Drain is zero. Okay, okay. Drain is zero. Gate is one.
gate, and source.
Okay, source and substrate. CMOS,
So we did.
NMOS. You have to write down PMOS instead of CMOS.
Sir, there was a PMOS.
Yeah, PMOS. It is not CMOS or nothing else.
Okay, okay.
This name is same as the name available in model file. If you see the model file, PMOS and NMOS is written. If you मैंने जो बताई ना model files में for
Okay,
all
sir.
and NMOS NMOS is written and for P model PMOS is so same you have to reflect. Otherwise there is a model file error will come. VDD is 201.8. This VDD okay VDS. This VGS between 1 and 0. No, it's not between 1 and okay. 1 and 0.
There is a zero as a drain, no, sir. So VGS, I means notation change. VG.
VG. VG between 1 and 0. That means gate and ground.
Yes, sir.
Yes. Uh, let me show you circuit. Can you stop sharing, Pujan? PMOS का ऐसा है, you have to apply VGS like this. This is substrate, and at the source you have to also apply VDA. Yeah, see. This is ground. Okay, this is the PMOS characteristics.
Sir, we can also apply a gate ground to the drain, na sir?
Yes, you can apply. Yes, you can apply.
So there was a zero was connected and gate ground was connected drain.
Yes. Can anyone else share their code? Maybe Nirali, maybe Jamin, Karan, Mangesh, Gunjan,
Yes,
Dhananjay,
sir.
Ayush.
Should
Can anyone share? Sivang is sharing. So bottom one, M12100. Okay, VDD, VGS 1 and 2. Okay, VGS 0. Okay, I of M1. Correct. Good, Sivang. So here you will see the graph of I of S instead of I of D, because it is ISD. Okay, Sivang, can stop sharing. So anyone else want to share? So I am planning on this Sunday with interaction with your senior, those who are at present in third semester, doing internship in various companies. This is just plan, not exact schedule. Anyone know your seniors? Those are in third semester. Anyone in contact?
Ankit Yadav.
Oh, Yankit Yadav. Yes.
Sir Parth.
Parth. Oh, roll number 13. Parth Wagela.
The surname, but I placed in
He's,
Qualcomm.
oh, he's from Surat. Yes, Parth Wagela.
Sarthak Jain.
Satvik. One? Who's?
Sarthak
Sarthak.
Jain.
Oh, he's in Intel, doing the work in the physical design. Okay, if anyone want to share the screen, they can. Otherwise, you can leave the meeting. If any question, you can ask. You can mail me. No problem. Anytime.
Where we can learn all the codes of PSpice. That okay.
PSpice is freely available. You can easily download. ngSpice is also freely available. Most of the Spice code are freely except HSpice. HSpice and TSpice not freely available. While ngSpice is fully available.
Sir, but code about code. What to do
Code,
about code?
code is not code you have to write down based on circuit. Code is not available. There is a use of design skill, engineer skill. Code is not available. You have to write down code based on your requirement, based on circuits.
Okay.
ये जैसे आप सी सी प्लस प्लस पढ़े थे इस टाइम पे भी कोड तो आपको कोई देता नहीं, यू हैव टू राइट डाउन कोड ऑफ एडिशन मल्टीप्लायर, ऐसा यहाँ पे है.
So syntax means syntax like 0, 1, 2 include it or at all.
Okay, I will give you one hint. If you follow my screen, stop sharing. Can anyone see this? Hello? Can anyone quickly reply?
Yes, sir.
Okay,
Yes, sir.
so go to here. Go to this insert command. Exactly above this green button, insert command, where you can find what you want to add. Suppose you want to do the AC analysis, if you want to do transient analysis. अभी जो हमने किया वो DC operating point, DC sweep analysis. Everything you can find. If you want to add current source, if you want to see the output, just define the numbers, no number here. That, let's say I am writing something 20 and then insert the command. So that command will appear here. No need to remember everything. Just enter the no number based on your requirement. You can insert the command. If you want to add the pulse, give the number, magnitude, for example, like this, and that will be added. It is a missing parameters. It will be added in the code. Let's say you are going to add the VGS between 2 and 0. Okay. So you have to give the peak amplitude, everything you have to give. Then and then that command directly insert in your code like this, pulse and everything. The insert command is that you can utilize here. Is it visible?
Yes, sir.
Okay. So if your email ID will be there, Nirma, I will definitely share this code and this software and everything. I try, but I got the failing message 2 or 3 times I try.
Sir,
Okay.
sir, sir,
Yes.
can you please explain the PMOS once again? Actually, my notation are is wrong. Very. Can you-
Okay. Okay. Mm, I am showing that circuit of PMOS. This one. So I am giving number also. These are the 1. Okay. These all are 0. Maybe 2 or 3 here. Okay. So M1 DGSS you have to remember. Gate is 1, 2, 2. This is also 0. This way you can utilize your tool.
Okay, sir. Okay.
So see you next time, next week with physical design, all the steps. If you any doubt, any query, email me. I will reply. Thank you for joining.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you, sir.